Dear students, under the topic graph theory, here we have lecture 6. In this lecture, we are going to learn the first problem under graph theory. The question is, let G be a P, Q graph, which means G has P vertices and Q edges, all of whose vertices have degree K or K plus 1. So they have degree K or K plus 1. For example, if one of the if few degrees are 2 and the other degrees will be 3, not more than that. So if we have a graph of that kind, and if G has t vertices of degree k, then we have to show that t is equal to p multiplied with k plus 1 minus 2q. We shall first check this condition for an illustration. Now we consider a graph over here. Let us check whether this relation satisfies for this graph. Now, first we shall take the value of p for this graph. P is the number of vertices. So, how many vertices are there? 1, 2, 3, 4, 5. So, there are 5 vertices. So, p is equal to 5. What about q? Q is equal to the number of edges. So, 1, 2, 3, 4, 5, 6. So, there are 6 edges. So, we have taken the value of p, we have written the value of q. What about the value of k? If you see, first let us check the degrees of each of the vertices. The degree of this is 2. This is 3. This is 3 and this is 2, and the degree of this is also 2. Now, I have taken a graph in such a manner that its degree is k or k plus 1. So, k is equal to 2, k plus 1 is 3. We do not have any other degrees. So, k is equal to 2. So, these are the values. Now, what about t? T is the vertices of degree k. So, number of vertices of degree k. K, that is how many vertices have degree 2? We have to check. So, 1, 2, 3. So, t is equal to 3. We will check whether these satisfy the relation given. So, left hand side is t. So, that is what t is equal to 3. We have to check for the right hand side. So, let us calculate that. P into k plus 1 minus 2q. We shall substitute the value of p. P is what? 5. K plus 1 is 2 plus 1, which is 3. Minus 2 multiplied with q. Q is what? 6. So, that is 15 minus 12, which is equal to 3. Therefore, the right hand side is also 3. So, t is equal to 3 and the right hand side is also 3, which means that this relation is satisfied. Now, we shall see the theoretical proof of this relation. So, in order to prove that, first we will write what is given. It is given that G is a P, Q graph, which means it has P vertices and Q edges. It is also given that G has t vertices of degree k. So that we will write. It's given that G has t vertices of degree k. So if it has t vertices of degree k, we know that the total number of vertices is p. And we also know that if a vertex does not have a degree k, it will have degree k plus 1 only, because only 2 is possible. It's given in the question. So, if t has k degree k, then this will imply G has p minus t vertices, that is the remaining vertices of degree k plus 1. So, in the problem, it is given that t vertices are having degree k and the remaining vertices are having degree k plus 1. And what are the vertices that are remaining? We have totally p vertices. If t has k, then p minus t are the remaining vertices, which will have degree k plus 1. Now, we are going to prove this with the help of the first fundamental theorem of graph theory. So, by the first fundamental theorem of graph theory, we know that summation degree of V, for V an element of capital V, is equal to 2q, twice the number of edges. This is by the first fundamental theorem. Now, this summation can be splitted up. How it can be splitted up? degree of those vertices with k degree and k plus 1th degree. So if we are splitting up in that manner, how many vertices have degree k? T vertices. So t multiplied with k plus, and how many vertices have degree k plus 1? We saw that it is p minus t. So p minus t multiplied with k plus 1 is equal to 2q. Now this summation of all the degrees is splitted up with those vertices with degree k and those vertices with degree k plus 1. So t vertices with degree k and p minus t vertices with degree k plus 1, and finally adding it up. And we know that it is equal to 2q. Now so let us simplify this. Now when we simplify this, we will be getting tk plus p multiplied with k plus p minus tk minus t is equal to 2q. Now from this we see that plus tk and minus tk gets cancelled, and from these two we can take p in common. So let me write it here. So p multiplied with k plus 1 minus t is equal to 2q. Taking this minus t to the other side and bringing this 2q to the other side. So let me write it in this way. T will be equal to p into k plus 1, this minus 2q. So therefore we have proved that t is equal to p multiplied with k plus 1 minus 2q, which is the required result that we have to prove. T is equal to p into k plus 1 minus 2q. So hence we have proved this problem. For more problems under this topic, kindly follow the upcoming video lectures. Thank you.